Good morning, students. So, in the last class, we discussed a lot of interesting aspects and concepts of LCR circuit in the resonance stage. I think one of the things which we missed out was the power. Now, let's talk about a power a bit. So, power, as you know, is nothing but VRMS, IRMS, and cos phi. Okay, now when it is the resonance stage, okay, then we know cos phi is equal to cos 0 is equal to 1. So I can say it is uh, power is equal to VRMS IRMS and into 1, or I can say VRMS is nothing but V naught by root 2 into I naught by root 2 into 1, correct? Or I can say V naught is nothing but IR, I naught R, okay, and this is I naught by root 2 into root 2 is nothing but 2. So power maximum is equal to I naught 2, which is the maximum, into R by 2. Okay, so this is the formula when when we talk about the LCR circuit and when we are talking about resonance. So when we are talking about resonance, we know XL is equal to XC and it's a pure resistive circuit, and phi is equal to 0 and cos 0 is 1, and that is what we have put in here. Now we draw a curve or a graph, then it will be something like this. This is power average, this is power average, and this is frequency. So the curve will be something similar to the one which we did earlier for current, F naught. So power average F, and this is maximum power maximum. Okay, now one more thing, this is what I naught square max, or I can say this is also equivalent to power max is equal to IRMS whole square R, and this is what we have spoken earlier, that if we have to calculate the current in the alternating, and we are calculating power, we have to calculate power and we have alternating current. So if we just consider as if the IRMS current is flowing, we can get to know the power just by the formula, which is I square RMS into R. Okay. Now let's quickly summarize whatever we have studied up till now. Okay. Now the first point is, at resonance, at resonance Z min is equal to R. Okay. Or we can say I naught max is equal to V naught by R. So basically what it says is Z minimum is when XL is equal to XC. So XL minus XC is equal to 0. So we are left with only R. Z minimum is equal to R. I naught maximum is equal to V naught by R. And I and V are in same phase, you know, means because XL is equal to XC, both are in the same phase, so angle between them is equal to 0. And what does it mean? It's a purely resistive circle. Resistive circuit. Okay, so this is point number 1. Point number 2. Let's talk about resonant frequency. Resonant frequency. So we know omega naught is equal to 1 by under root LC, or we can say F naught is equal to 1 by 2 pi under root LC, or I can say XL is equal to XC, which we have already discussed at resonant frequency. This is equal to this, and that is what we spoke about. Now, resonant frequency is dependent of L and C, means it can be changed as per if we change L and C. Now also we can put one more point. There is no effect of frequency by value of R. Right. Finally, but R affects I naught maximum and we can say I naught max is equal to V naught by R. Okay. So resistance will affect fineness of tuning. Okay, now if we have to draw a graph, we can say, we can draw it like this. Graph would be what? This is FO, F frequency, and let's say we have 3 curves like this, then we have like this, and third, let's say this. So these are actually at the same frequency, and here the resistance is R, and here it is 2R, and here let's say it is 4R, and let's say this is what? These are the peaks. Let's say this is 2.5 ampere, this is 5 ampere, and this is 10 ampere. Okay, so this explains resistance is very much needed. There is no effect of resistance on the resonant frequency. However, resistance will alter the current, and as you see, it will affect the fineness. For example, if resistance is very high, then the current would be very less here. Okay, and if resistance is very high, the power loss would be very high as well. Why? Because we know that P max is equal to IRMS whole square into R is nothing but I naught square by 2 into R. Okay.